We continue with the second way of estimating fixed effect via within estimation. First, let's try to run the command of fixed effect within estimation. There are two commands that can be used to estimate fixed effect within estimation. First is extract y x1, fe. Fe is the option we tell Stata regarding the types of panel model that we want from the extract command. The second is array y x1, absorb in bracket country. This array command is the absorb regression command, and inside the bracket we specify to Stata the effect from which variable that we want to absorb. In this case, we want to absorb the effect from country. Before we proceed to Stata to try the command for ourselves, let's have a look at the results first. We can clearly see from the result that the coefficient estimates of x1 is consistently identical to the one that we obtained from LSDV estimation earlier, which is 2.48. Regardless of command that we use, either extract or array command. Let's head to Stata and try for ourselves the command. So we write the command here extract y x1, fe and press enter. Then array y x1, absorb in bracket country. Press enter. Both results are identical to what we saw just now in the slide. Let's go back to the slide. After we get the results, let's understand further about the within estimation model. Here is the explanation about the within estimation. Recall this equation 3 where we include a notation of VI into the model to capture the unobserved heterogeneity factor that is specific to each country in the model. Within estimation, firstly transforms the original observation into time average model by the notation of y bar equal to Vi plus beta 1 x bar plus u bar. Remember, now there is no more t here because it is a time average value of the original observation. So it means that we take time average for all the variables in the model. Here, we sum all y for each country for each period. Let's say we take Australia data, we sum all the y observation for each year and then divide by number of years. So it means that we are going to get the y bar for Australia, which is the average value of y throughout the sample periods. The same goes to x, and eventually we can assume that the error term in this average model is going to be the average error term. However, the Vi is constant. Therefore, an average of a constant will be itself. Therefore, Vi will remain in our average equation. Let's go to the next slide. So what within estimation does afterwards is converting the original data into time domain data or deviation from individual mean data by taking the original equation, the equation 3, minus the average equation, the equation 4 just now. So when we take the original observation of y minus the average of y, then we are going to get what we call the deviation from individual mean data. We often show the notation for the deviation from individual mean model as y double dot. Y double dot equal to beta 1 x double dot plus u double dot. We no longer have v now because v will be eliminated. The average is the v itself. So v minus v, then v will be gone. So in other words, the transformation by the within estimation, it captures and controls the unobserved heterogeneity factor Vi, and finally giving us the correct estimate of the coefficient x1 on y. Remember, if you do the transformation manually, then you are left with the time domain data in your data set. You can simply run OLS on the time domain data. But you don't have to do the transformation manually. In Stata, what we did just now, using xtrect yx1 command, xtrect yx1 comma fe, so we tell Stata to use xtrect command and to estimate within estimation, so fixed effect within regression, then Stata knows it must convert the original observations into time domain first before running the regression. So in Stata, it will be done automatically. So you don't have to worry about doing the transformation. You just run this command and Stata will transform the observations into time domain data and run the within estimation on the transformed data. So let's go back to the slide. And to conclude this topic 4, the overall idea in fixed effects model is that it allows for the presence of unobserved heterogeneity factor in the dataset, and fixed effect captures it via dummy variable. Recall the least square dummy variable model that we did just now. Or it eliminates it via time domain transformation to the original observations, or it absorbs the unobserved heterogeneity factor via a rect command that has absorb option. This is the end of the topic 4, discussing the second model of panel data, namely fixed effect.